Now we are discussing about the conditions required for the stable operation of the Wein bridge oscillator circuit. Initially, there is no doubt. Initially, the circuit gain A beta should be greater than or equal to 1. Then only from the small amplitude it will increase the amplitude. But once it reaches a certain amplitude, in order to maintain the stable operation, the conditions are: one is phase shift should be 0. The phase shift 0 should be maintained by using this RC circuit. Here the phase shift is 0. And A beta must be equal to 1, where A is the gain of the operational amplifier and beta is the feedback factor, beta. Because A is equal to 3, initially A is greater than, if A beta is greater than 1, then the oscillations are happening like this. But for the stable operation, later A beta should be equal to 1. When A equal to 3, then beta should be equal to 1 by 3. But what is the gain of the operational amplifier when we connect it in non-inverting mode? Because we are giving this here VD, the output of this Wheatstone bridge, as an input to the non-inverting terminal of the operational amplifier. So A is equal to 1 plus RF by R1, because we are connecting this in the non-inverting mode. If we are connecting in inverting mode, then A is equal to minus RF by R1. Here you remember clearly, we have to consider R3 as the feedback resistor. Why, I will explain now. See here, from the output, we have connected only to this branch and to this branch. There is no direct connection from output to R4. So the feedback resistor is R3 only. So in place of the feedback resistor, I have to write R3 and R3 by R4. When we are writing 1 plus R3 by R4, then 3 is equal to 1 plus R3 by R4, then R3 by R4 is equal to 2. We have to maintain R3 is equal to 2R4. Definitely, the value of the R3 must be greater than R4, and we are giving the value. If A is equal to 3, we maintain. If A is equal to 3, we maintain, then beta value should be 1 by 3, then the R3 value should be double of the R4. Then this R3 value should be 2R4. If we are taking the R3 is equal to 2R4 and we are maintaining A is equal to 3, then as usual, because we are getting the 0 degrees or 360 degrees phase shift from the input to the output, it is obeying the two Parkinson criteria conditions. One is phase shift 0 between the input and output at the resonant frequency, and A beta is equal to 1. For that, we are maintaining beta is equal to 1 by 3. When we are maintaining these 2 points, then we will get the stable operation by using the Wein bridge oscillator. See here, if A beta is less than 1, example, if R3 value is less than 2 or 4, then you see, initially the output is high, slowly the output is becoming 0. If A beta is greater than 1 or R3 greater than or equal greater than 2 or 4, then initially output is 0, slowly it is rising continuously. We expect for the oscillator to initially rise the voltage until a certain level. After that, it has to maintain sustained oscillations. There should not be any damping, over damping oscillations. Over damping or under damping. It should be critically damped. A beta must be equal to 1. When A beta becomes 1, then stable operation. In this condition, the stable operation will be observed. At this condition, A beta is equal to 1. But there is no doubt. Initially, it will rise like this. Initially, A beta is greater than 1. But here the heading we have taken for the stable operation, to sustain the operation, A beta must be equal to 1.